Hi everyone, I'm your friend Shadab Imam and we are continuing our lecture series on operations research. If you are new to the channel, please subscribe the channel and don't forget to hit the bell icon. So currently we are dealing with the transportation model, and in the previous lecture we have seen the introduction of the transportation model where we have seen what transportation model is and what are the assumptions we take in the transportation model. We have also seen the formulation in the linear programming form as well as the representation in the matrix form, and we have seen that the problem of transportation can be solved in two parts. First is to get the basic feasible solution and the second is to check for optimality, and we have seen the conditions that needed to be a basic feasible solution. So today I have came up with a very interesting problem which will make your concept about the transportation model. So let us start with the problem. The problem here says that there are three plants 1, 2 and 3 with supply as 6, 1 and 10 respectively, and there are 4 distribution centers 1, 2, 3, 4 with the requirement as 7, 5, 3 and 2, and the unit transportation cost from source I to the destination J is given as, it is given in hundreds of rupees. That means the unit transportation cost, that means transportation cost of 1 unit from plant 1 to distribution center 1 is 200. Similarly, the unit transportation cost from plant 1 to distribution center 2 is 300, and so on. And now, as we know that the transportation problem can be solved in two parts. First is to get the basic feasible solution, and second is to check for optimality. So in this lecture we are going to see different methods to find out the basic feasible solution for a transportation problem. So in transportation problem, to find out the basic feasible solution, we generally use 3 methods which are very popular. First among them is the northwest corner rule. So let us see this first, northwest corner rule. So here, as we can see that I have already drawn a matrix, and the transportation cost, or I should say the unit transportation cost, has been represented at the top left corner of the cell, and this is the standard way of representing the unit transportation cost in a transportation matrix. And first of all, before starting to solve the question, we need to identify that if our problem is a balanced problem or an unbalanced problem. So let us see, for a balanced problem, the total supply has to be equal to total demand. So let us see the supply: 6 plus 1, 7 plus 10, 17, and the total demand or requirement is 7 plus 5, 12 plus 3, 15 plus 2, 17. So here we are satisfying our condition where we need to have the total supply equal to total requirement or total demand. Now proceeding forward, we will see that in northwest corner rule, what we will do is we will select the northwest cell in the matrix. Suppose in this particular matrix, the top left cell is the northwest cell. So whenever we are doing allocation, what we will do is we will select the northwest cell and we will allocate the maximum number of units as we can. So here we can see that the northwest cell in this particular matrix is this one, cell 1 1. So we will try to allocate as much as possible. So we can see that plant 1 has the supply of 6 and the distribution center 1 has the requirement of 7. So among these two we will select the minimum value. That means out of the 7 requirement, 6 can be fulfilled by plant 1. So we will allocate here value 6. Now as this has been fulfilled, no other allocations can be done here. So I am just crossing it out. That means this value has been fulfilled and we don't require any other allocation in this particular row for plant 1. Similarly, we can see that out of 7 requirement, 6 are fulfilled and only 1 is left. So now again in the remaining matrix we will select the northwest cell. So for this particular matrix, the northwest cell is this one. So we will try to allocate maximum on this particular cell. So we can see that plant 2 has a supply of 1 and distribution center 1 has now the requirement of 1. That means this value 1 can fulfill this. Now the requirement is 0 as this 1 has been fulfilled and here the supply has been fulfilled. That means no other allocations can be done here, and similarly no other allocations can also be done here as this is fulfilled. Now in the remaining 3 cells we will select the northwest corner cell, but because there are only 3 cells or a single row, we are forced to allocate the remaining values in these particular cells. So we have no option but to allocate the values in the corresponding cells. So 5 I have allocated here, 5, 3 and 2. That means this is fulfilled, this is also fulfilled and this is also fulfilled. So after allocating 5 here, 5 is remaining. Similarly after allocating 3 out of 5, only 2 is remaining, and after allocating 2 here we have 0 units remaining. So now as we can see here that all the supply and demands are fulfilled. That means they came to 0. So all the demand and supply are fulfilled. Now we need to calculate the value of Z, that means transportation cost. So the transportation cost here can be given as number of units multiplied by unit transportation cost. That means the transportation cost of 1 unit is 200 and for 6 unit is 6 multiplied by 200. So we will write 2 into 6. Similarly here is another allocated cell plus 1 into 1. Similarly here is one allocated cell which is 8 into 5 plus 15 into 3 plus 9 into 2 and into 100, because it has been mentioned that the transportation cost is in hundreds of rupees, and this will come up as 12, 13, 40. This will come up as 11600, 11600 rupees. So this is the value of Z for northwest corner rule. So let me write here, Z is coming as 11600 for northwest corner rule. Now we need to understand something, that we have seen that for a solution to be a basic feasible solution, it must satisfy 3 conditions. The first one is that all the supply and demand must be fulfilled. So we can see here that all the supply and demand are coming to 0. That means all the supply and demand are fulfilled. The second is that there should be non-negativity restriction. That means all the cells must have either 0 allocation or greater than 0. So we can see that the cell in which there is no allocation will have 0 value. That means there is no transportation of any unit out there, and where we have allocation we have all the positive values. So our second condition also satisfies. Okay, so here we can say that this is and the third condition, that the problem must have m plus n minus 1 number of independent allocation. So m is the number of row 3, n is the number of column 4, 3 plus 4 minus 1 is 6. So m plus n minus 1 is equals to 6. But as we can see in this problem that there are 5 number of independent allocation and they should not form loop. Now here we can see that what is loop. Whenever we are starting from a allocated cell, we can move either vertically or horizontally and move alternatively around a allocated cell. So if I move from here, I can see that there is no such allocation, there is no such allocation, and similarly if I move from here, there is no such allocation, there is no such allocation. That means it is not coming back to the starting point, hence there is no loop, and these 5 allocations are independent allocations. Now as per our need, the basic feasible solution must have exactly m plus n minus 1 number of allocation, and m plus n minus 1 is 6. So there should be 6 number of allocations, but here we have only 5 allocations. So whenever we have number of allocations less than equal to or less than m plus n minus 1, as in this case the total number of allocation is 5 and m plus n minus 1 number of allocation is 6. So whenever the number of allocation is less than m plus n minus 1, then it is a case of degeneracy. Okay, it is a case of degeneracy, and this states that there is one potential cell here available after allocating where we will not form a loop. That means there is still one possible allocation can be made, and generally what we do is for calculating the optimality or for checking the optimality, we will select a cell and put a value epsilon there, and the value epsilon means null value. That means it has 0 allocation. So we will select any cell such that it will not form a loop. So we will study that whenever in the coming lectures when we are solving the problem with degeneracy. Here we are only focusing to find out the basic feasible solution. So here we have obtained our basic feasible solution through northwest corner rule, and the value of z here is coming as 11600. So now let us move on to the next method, which is the least cost method. Least cost method, and let us see how to solve this method. So in order to solve, I will just erase this. Now in the least cost method, what we'll do is we will focus on the least transportation cost given in the matrix table. Okay, we will focus on the least transportation cost given in the matrix. So let us see. So let us see in this particular matrix how can we solve this. So in this matrix we can see that which one is the least, which cell is having the least transportation cost. Then we can see that here the unit transportation cost is 0. That means this is having the least transportation cost. So we will try to allocate as much as possible in this particular cell. So in this particular cell we can see that plant 2 has a supply of 1, and this plant 2 distribution center 2 is having the requirement of 5. So out of 5, 1 can be fulfilled. So we have allocated 1 here, so that this will become 0. So that this will become 0, and no other allocation can be done here. So no other allocation can be done here. Similarly, out of 5, this has been reduced to 4. Now distribution center 2 requires 4 as 1 has been fulfilled. Now from the remaining eligible cells, we need to select minimum transportation cost. So here we can see that cell 1 is having the minimum transportation cost, that is 2. So we will see that plant 1 has the supply of 6 and the distribution center 1 has the requirement of 7. That means out of 7, 6 can be fulfilled. So we have allocated 6 here. That means now we have 0 supply here, and out of 7, 6 has been fulfilled and only 1 is remaining. So once this is fulfilled, we can exit out this row, so that no allocation can be done here because the supply has been exhausted. And now in the remaining row we have only single row. So now we are forced to allocate the remaining values in this particular cells, so that because we do not have any other options. So let us allocate here. So this will be 1, this will be 4, this will be 3, and this will be 2. So after allocating this, we have 0 because 1 has been allocated, 0 because 4 has been allocated, 0 because 3 has been allocated, 0 because 2 has been allocated. Similarly, out of 10, 1 is allocated here, 4 is here, 3 is here, 2 is here. That means all the supply 10 has been distributed. So now we have got another basic feasible solution, and we can also check here the conditions that if this is a basic feasible solution or not. The first condition is that all the supply and demand has to be met. So all the supply and demand has become 0. That means the demand and supply are fulfilled. Second is that the non-negativity restrictions. So we can see that all the values are either 0 or positive. Similarly, we can see here that the number of allocations, now in this particular portion we have 1, 2, 3, 4, 5, 6 number of allocation, and for basic feasible solution we have m plus n minus 1 number of allocations, which is equal to 6. So it is satisfying this. That means this is a basic feasible solution we have obtained by the method of least cost. Now to calculate the value of z, again we'll do is 2 is the unit transportation cost, and 2 multiplied by 6 is the total transportation cost from plant 1 to distribution center 1. So this will be 2 into 6. Similarly, plus 0 into 1. Similarly, 5 into 1 plus 5 into 1 plus 8 into 4 plus 15 into 3 plus 9 into 2 multiplied by 100. So after calculating this, 12, 5, 13, we will have the value as z equal to 11200 rupees. That means by solving this by least cost method, we are getting a basic feasible solution with the value of z as 11200. So here we can write there z equals to 11200. Now we have another method to find out the basic feasible solution, and it is called Vogel's approximation method. Vogel's approximation method, or we can say penalty method. Okay, so let us see how we can solve by Vogel's approximation method. So I am just erasing this. So to solve by Vogel's approximation method, what we'll do is we will take the difference of least value and the second least value in each row and each column. And why do we take it? Because in the previous method, in the least cost method, we have taken the least value so that maximum allocation can be done here, but it does not give any idea that if the complete allocation has been not done here, then which cell is to allocate. So in the Vogel's approximation method or penalty method, what we will see is that if it has been allocated to the minimum transportation cost value, so the remaining allocations has to be allotted to the cell which is having the second lowest transportation cost. So in order to do so, we will calculate the difference between the lowest transportation cost and the second lowest transportation cost in each row and in each column, and we can call it a penalty. So higher will be the penalty and greater will be the transportation cost. So we will try to fulfill those cells which have higher penalties. So let us first calculate the penalties. So in this we have least value as 1 and the second least value is 2. So the difference is 2 minus 1. So here we can write this as 1. Similarly, we have 0 here, least value, and the second least value is 3. So 3 minus 0 is 3. Here the lowest value is 6 and the second lowest is 11. So the difference is 5. So here it is, penalty is 5. Here the least value is 1 and the second least value is 7. So the penalty is 7 minus 1 is 6. Similarly, we will calculate for row. The least value is 2 and the second least value is 3. So the difference or the penalty here is 1. Similarly, the least value is 0 and the second least value is 1. So the penalty is 1. Similarly, here least value is 5 and the second least value is 8 and the difference is 3. So 3 is the penalty here. Now, once we have calculated the penalties for each row and each column, we will select the maximum penalty. So we can see that the maximum penalty is 6. So we will select this particular column and among this particular column we will select the cell which is having the lowest transportation cost. So as we can see here that 1 has the lowest transportation cost, that means we will try to allocate maximum here. So we can see that in this particular cell there is a supply of 1 and a demand of 2. That means out of 2, 1 can be fulfilled. So we have allocated 1 here, and that means no further allocation can be done in this particular row. So this will be 1 because 1 has been allocated and this has been fulfilled, that means it is equal to 0. Now among the remaining cells we will again calculate the penalty. So as we can see that row 1 and row 3 does not change, so the penalty will remain 1 and 3, and in the column let us calculate the penalties. So this is 2, second least is 5, 5 minus 2 is 3, so here the penalty is 3. This is 3 and this is 8, the difference is 5, so here penalty is 5. Here lowest is 11 and second lowest is 15, difference is 4, so penalty is 4. Here the lowest is 7, second lowest is 9, so the difference is 2. Now among these we can see that the maximum penalty is 5. So now we will select this 5 and we will try to allocate in this particular column. Now in this particular column we can see that there are 2 active cells which are having the cost as 8 and 3. So we will try to put here because this has the minimum transportation cost. So in 3 we can see that we have a supply of 6 and a demand of 5. So out of 6 supply, 5 can be fulfilled. So we can allocate 5 here. That means no more allocation can be done in this cell. No more allocation can be done in this cell. And here out of 6, 5 have been allocated and only 1 is remaining. So again from the remaining cells we need to calculate the values of penalty. So as column 1, 3 and 4 does not change, the penalty will remain the same. That means 5 minus 2 is 3, 15 minus 11 is 4, 9 minus 7 is 2. And we will calculate the row penalties. So the active cells are this. So this will be 2 is the least and 7 is the second least. So 7 minus 2 is 5. So 5 is the penalty. Similarly here 5 is the least and 9 is the second least. So value 4 is here. Now among these values we can see that the maximum penalty is here at 5. So we will try to allocate here in this particular row. Among this we have 3 cells. So we will select the cell with minimum transportation cost, that is this cell, cell 1 1, and as we can see here we have a supply of 1 because 5 have been already there. So we have supply of 1 and we have demand of 7. So out of 7, 1 can be fulfilled. So we have allocated 1. That means this has been completed and no further allocation can be done here, and this has been come to 0. Now out of 7, 1 has been allocated and this is come to 6. 5 has also been allocated, so this will be 0. Now as we can see here that only a single row is remaining, and because there is no other options we are forced to allocate the remaining values in these cells. So as we can see here 6 is allocated here, 3 is allocated here and 1 is allocated here, and the values is 6 is been allocated, so 3 has been allocated and 1 has been allocated. Similarly 6 plus 1 3 9 plus 1 10, all the 10 has been fulfilled. Now let us see here that this is the basic feasible solution we have obtained from Vogel's approximation method or penalty method, and again we will check that if our solution is a basic feasible solution or not. And to be a basic feasible solution, it must satisfy three conditions. First is that all the supply and demand should be met. As we can see here all are 0, that means all the supply and demand are met. Second is non-negativity restrictions, that means in all the cells there must be either 0 allocation or positive allocation. So we can see that there is no negative allocation, that means we are fulfilling that particular point. And the third one is we have to have m plus n minus 1 number of allocations. So here we have 1 2 3 4 5 6 allocations, and as we know that m plus n minus 1 number of allocation is equals to 6 for this particular matrix. So we are fulfilling all the criteria for being a basic feasible solution. That means this is our basic feasible solution. Now let us calculate the value of z here. This will be 2 into 1 plus 3 into 5 plus 1 into 1 plus 5 into 6 plus 15 into 3 plus 9 into 1 into 100. So this will come up as, this is 15 plus 45 60 okay, 15 plus 45 60 62 92 and 9 101 again. See 5, this will be 15 45 60 62 and 72 and 30 102. So this will become 10200 rupees. So the value of z coming here is rupees 10200 rupees. So as we can see here that for different methods we are obtaining different value of z, that means transportation cost. And we need to understand that as we can see among the three, the Vogel's approximation or penalty method is giving us the lowest value of z. So why is it so? Because in the northwest corner rule we are just arbitrarily allocating the allocations in the northwest cell without having any criteria, and in the least cost method we are selecting the minimum transportation cost cell, which has improved the solution from northwest corner rule. And in the Vogel's approximation method, what we are doing is we are going one step ahead and we will be calculating the penalty so that we can allocate, once we have fulfilled the minimum cost, we can allocate the remaining into the other minimum cost cell. So that's why Vogel's approximation method gives us slightly better solution than northwest corner rule and least cost method. But it is not compulsory that it will always happen, because as we can see in all the three cases the last allocations we have done are forced allocations, because in the last allocation we have only single row and we do not have much choices to make to allocate in this. So these are called forced allocation, and because we don't have choices there may be differences in the value of z here, and it depends on the transportation cost in these particular cells. Suppose if this value of transportation cost is not 5 or something else greater value around 15 or 20, that means our transportation cost will be increased. So here we have calculated the basic feasible solution, and in the coming lecture we are going to see how to check the optimality and how to improve our solution if our solution does not become an optimal solution. So have a nice day. If you like the lecture, please share the lecture. Thank you.